Welcome to qnawire.
Let's find the derivative of this function and show that it is what they gave us in the book as a formula to prove. So we're going to use the product rule. We have the first factor and the second factor. So the first is the sine of x to the n power times the derivative of the second. So the derivative of cosine nx would be negative sine of nx times n. So that's the chain rule, derivative of the outside times the derivative of the inside. Now we have plus the second, cosine of nx, times the derivative of the first. And the derivative of sine of x to the n power would be n times sine of x to the n minus 1 power times the derivative of sine, which is cosine, so cosine of x. Okay, now we're going to factor out the common factors. So we have a term here, and we have a term here, and they both have a common factor of n. So we're going to factor that out. And they also both have a common factor of sine of x to the n minus 1. So we'll factor that out. So what remains then in the first factor is that extra sine of x as well as the negative sine of nx. And what remains in the second factor is the cosine of nx times the cosine of x. Okay. Now I'm going to rearrange that last quantity a little bit. I'm going to write it as cosine nx times cosine x minus sine nx times sine x. Now, hopefully that looks somewhat familiar because hopefully when you learned trig identities in your pre-calculus class, you learned some angle addition identities. So cosine of alpha plus beta equals cosine alpha, cosine beta minus sine alpha, sine beta. That's what we have if we let alpha be our x. Where are we? Right here. And we let alpha be our nx and we let beta be our x. So then what we have is n times the sine of x to the n minus 1 times the cosine of alpha plus beta is the cosine of nx plus x. And then what we could do with that is we could factor the x out of both of those terms there. So we have n times the sine of x to the n minus 1 power times the cosine of n plus 1 times x. And that's what we set out to prove. Now we're asked to do something just like that for this one. So again, we're going to use the product rule. So we have the first, cosine of x to the n power, times the derivative of the second, and we need to use the chain rule, and we're going to get negative sine of nx times n, the derivative of the inside, plus the second, cosine of nx, times the derivative of the first. So again, using the chain rule, we're going to bring down the n, raise cosine to the n minus 1, and then multiply by the derivative of cosine, which is negative sine. Now we have these two terms, and let's see what we can factor out of both. So they both have an n, so we'll factor that out. And they both have cosine of x to varying powers. We can factor out cosine of x to the n minus 1 power. And they both have a negative, so we can factor that out. Okay, so what do we have left then? In the first term, we still have our leftover cosine x, and we have a sine of nx. And in the second term, we have the cosine of nx, and we have the sine of x. So hopefully when we look at this expression, we remember, again, those trig identities. The sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. So if we let alpha equal nx and beta equal x, then we have the sine of nx plus x. So we'll rewrite our quantity inside the brackets as the sine of nx plus x. And finally, we could factor x out of both of those terms, and we get our formula here, which will be negative n times cosine of x to the n minus 1 power times the sine of n plus 1 x.